Let's look at how to run a Gromacs simulation on Rescale. Gromacs is an open source molecular dynamics simulation tool that can be used to investigate various interactions between molecules like proteins, lipids, and nucleic acids. The example that we'll be looking at today is the simulation of a system with the lysosine protein in a box of water with ions. And the simulation files along with the tutorial were prepared by Dr. Lemke at the Virginia Tech Department of Biochemistry and are available at mdtutorials.com if you want to take a look. To get started with our Gromacs simulation, we could use one of the existing templates that we've created here, but instead let's click the Create a New Job button from the Rescale Scalex homepage to set up a job from scratch. We'll start by giving the job a name and then follow the steps here in the central diagram. The first page prompts us to attach our input files, which we can upload from our local machine, or if we've already uploaded them for another job, we can attach them from the Rescale cloud storage using the button there. In this case, we'll upload the files from our local machine, so we'll click the button and then select this zip file from our desktop. This zip file contains a partially complete version of the file set with much of the model preparation already completed, and all that's left for us to do is to complete the two equilibration steps and then run the actual molecular dynamics simulation. Once the input files have been uploaded, we'll progress to software selection by clicking the button in the diagram. And at this step, we select the software tool that we'd like to use. So we'll select Gromacs and then choose the version that we want. Rescale offers support for multiple versions of our simulation tools, including GPU-enabled versions, and these tools can be paired alongside each other for multi-stage workflows. Next, we'll need to tell the software what to do, so we'll enter in some execution commands here in the command box. We can see the zip file in the list of input files above the command box, and any zip file that we've uploaded as an input to Rescale will automatically be unzipped for us, so we can simply enter our execution commands without having to worry about potentially forgetting about unzipping our inputs. The commands that we're entering here will trigger the remaining 3 steps of the simulation, and when we're done copy and pasting them in here, we'll click hardware settings to move on to the next step. So this is where we'll want to select the hardware that we want to run the simulation on. The list of available hardware is curated by Rescale, and it's automatically filtered so that we can only select hardware types that will work with our chosen software. The available hardware options are broken out into various categories like high-speed interconnect and high clock rate, which help us easily choose what's the best option for our simulation. Here we'll leave the selection as Emerald, which has an Intel Xeon CPU, and then increase the number of cores to 36 to speed up the simulation. We'll set a wall time limit of 2 hours, which should be plenty, and then scroll to the bottom and click Next to progress. The last step in the setup would be to attach an optional post-processing file, but instead we'll be taking a look at the results interactively, so we'll leave this blank and click Next, and review our setup. Everything looks good, let's click Save and then Submit. After submitting, the job will be taken to this status tab where we can track the progress of the simulation. This page gives us updates as the job starts and then provides tools for live monitoring the job. The job can take a minute or two to start up, so let's switch over to an identical version of the job that's already running, and we can navigate back to our jobs page to do this. So let's do that and then select the running job. We can now see some of the options available to us for tracking the job progress. We can view files that are generated as the job runs by clicking them here, including the log file to ensure that things are progressing as expected. If necessary, we can also connect directly to our job to issue commands interactively. We can do that through a local terminal or in browser by clicking the button in the SSH section. But what we want to do here instead is we actually want to view the final results of the job without ever having to download any of them to our local machine. So we'll navigate to the desktop section up here by clicking the button at the top of the screen, and this will bring us to our main page where we can create and deploy virtual desktops. We have one running already, which we'll connect to in a minute, but first let's take a look at the setup by clicking the Create New Desktop button. Desktop setup is very similar to the job setup that we just completed. We'll give the desktop a name and then we're prompted to select the software and hardware options. For this example, we'll be visualizing the results using BMD, so we'll select it and then choose this Citrine hardware option, which gives us an 8-core node with a dedicated GPU. The last step is to attach result files from the job that we just ran. So we can expand the job section and we can easily see our jobs list here. We can see the job that we created, the running job, and then a completed version of that same job. So we can attach it by clicking the box next to it. The job can take about 10 minutes to complete this one on 36 cores. So here we'll just use the completed version of the run. And instead of launching this one, we'll actually switch over to the desktop that we've already got running. So let's click back and then click our desktop. And then if we go into the setup, we can see the green check mark next to the job, meaning it's attached. So let's click connect and take a look. We can launch VMD by clicking the shortcut shortcut on the desktop, and then we'll resize some of these windows to make things easier to see. So to start, let's load in the structure by selecting it, and then click load, and we can see it on our graphics area here with the water surrounding the protein. Let's take a look at the results by clicking load again and then browsing to our XTC file, which will let us visualize the interactions. We can now see the system moving, but as a final step, let's filter the view so that we're just looking at the protein, which we can then zoom in on and animate. So to recap, we were able to run a Gromacs molecular dynamics simulation on Rescale, track the progress of the job, and then visualize the results without having to download any data. Thank you.